All right, here we have 12.8 probability of compound events. Here we have a couple definitions. So compound events consist of two or more events linked by the words and or the word or. When two events have no outcomes in common, those events are called mutually exclusive. If A and B are mutually exclusive, then the probability of A and B equals 0. When we have events that have at least one outcome in common, we call that overlapping events. And here we have a couple key concepts. So if two events are mutually exclusive, then the probability of A or B is going to be probability of A plus probability of B. So you want to go ahead and write this in your notes. And probability of A and B of our overlapping events. So probability of A or B is going to be the following formula. So we're just going to head and subtract what they have in common there. All right, suppose you spin a spinner that has 20 equal sections numbered from 1 to 20. So that's going to look like, or I'm going to partially draw it out. And so you would have the numbers 1, 2, 3, 4, dot, 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 all the way to the numbers 20. And I obviously need more spaces there, but you kind of get the idea. So we have to determine if this is mutually exclusive or an overlapping event. So what is the probability that you spin a 2 or a 5? Can we spin a 2 and a 5 at the same time? No. So therefore it is mutually exclusive. And so therefore probability of 2 or 5 is just going to be probability of 2 plus probability of 5. So probability of 2, we only have 1, 2, so that's going to go on the top. And in total we have 20 different spaces we could land on. Plus probability, oops, this should be a 1 because we only have 1, 2. All right, and then probability of 5, we only have 1, 5 where we could land on, so that's going to be a 1. And then we have 20 different spaces. So in total, when we add those together, you get a 2 out of 20. And then you're going to go ahead and divide these. So you get 1 divided by 10 would be our final answer. And you want to leave it in fraction form for every single thing that we're doing in these two sections, 7 and 8. So what's the probability that you spin a number that is a multiple of 2 or 5? So is there a number between 1 to 20 that is both a multiple of 2 and a multiple of 5? Yes. So then these are overlapping events. All right, and then I'm going to put probability of, I'm just going to abbreviate multiple of 2 or multiple of 5. So that's going to be probability of multiple of 2 plus probability of multiple of 5 minus probability of multiple of both. So how many multiples do we have of 2 in between 1 and 20? That's going to be 10. And then we have a total of 20 spaces that we could land on, plus probability of multiples of 5. We have 15, 20, 5, and 10. I did it in a random order. So that's going to be 4 out of 20. And out of these multiples of 5, how many of those are multiples of 2? So 20 and 10 are multiples of 2. So we're going to go ahead and subtract the ones that were multiples of 2 and 5. That would be 2 out of 20. So notice all my denominators are the same. That should always be true. Okay, and then I'm just going to go ahead and add these. So that would give me 12 over 20. And then go ahead and simplify. So I could divide both of these by 4 and I get 3/5. So that would be my answer. All right, key concept. So if two events are independent, then that means that one event does not affect the other, and in that case, we have this formula right here. All right, so example number 2 says, suppose you roll a red number cube and a blue number cube. What is the probability that you will roll a 3 on a red and an even on a blue? So these are independent events because if you roll the red die, then it doesn't matter what you get on the even or on the blue dice. So we're going to go ahead and say independent events. And probability of 3 or even. So probability of 3 times probability of even, and then I'll kind of color code this so the 3 was on the red and the even was on the blue. Alright, so they're talking about a dice here. They say cube, but they are talking about a dice. Alright, so on a dice you have 6 different outcomes. So I'm going to put 6 for the total on the bottom. And then we only have 1 3 on a die, so that would be 1 6. And then even, we have 3 different even numbers on a dice. So we could go ahead and we could cross cancel before we multiply. So 3 divided by 6, that would be 1 and 2. So then we're going to go ahead and multiply that. We get 1 over 12. And that would be our answer. Alright, example number 3 says you choose a tile at random from the game tiles shown. You replace the first tile and then you choose again. What is the probability of choosing a dotted tile and then a dragon tile? So because you are replacing, these are independent events. And so probability of dotted, then dragon is going to be probability of dotted times probability of dragon. Alright, so probability of dotted, we have 1, 2, 3, 4 dotted tiles, so that would go on the top. That's our favorable outcomes. And then we have a total of 15 tiles. Alright, then probability of a dragon, so we have 1, 2, and 3. That would be 3 out of 15. And then you could try to see if you could simplify. So the 3 and the 15, I could simplify that 1 and 5. And then you're going to go ahead and multiply those. So that would give you 4 on the top. And then on the bottom, you would get 75. Alright, what happens when when we have dependent events? So in this case, a dependent event is where one event affects the other. And in that case, we have a new formula now. And it just means that you get probability of A times probability of B after A. So for example number 4, suppose you chose a tile at random from the tiles shown in problem 3. Without replacing the first tile, you select a second tile. What is the probability that you choose a dotted then a dragon? So in this case, we do have dependent because we have one less tile to choose from. So we're going to go ahead and get probability of dotted then dragon. That's going to be probability of dotted times probability of dragon after dotted. So for dotted, we still have 1, 2, 3, 4 out of 15. That's still the same. And now that we have taken one away, I'm just going to say a random one, we have 14 now. And then we have to think about the dragons that we have. So we still have 3 dragons. And now we're just going to simplify. So the 4 and the 14, I could divide that by 2. That would give me 2 and 7. And then the 3 and the 15, I could divide that by 3. That would give me 1 and 5. In total, we have 2 over 35. And that would be our answer. All right, and our last example, suppose you have 1 freshman, 2 sophomores, 4 juniors, and 5 seniors that receive scores in a school essay contest. To choose which 2 students will read their essays at a town fair, 2 names are chosen at random from a hat. What is the probability of a junior then a senior? So you choose one, and then that means that there's one less to choose from. So these would be dependent events. So we have probability of junior then senior. That's going to be probability of junior times probability of senior after junior. So in total, we have 12 students. And so for probability of junior, it would be 4 out of 12. Then for probability of senior after junior, since one person has already been chosen, that's going to be 11. And we have a total of 5 seniors. So we're going to go ahead and simplify. 4 over 12 is 1/3. And then we're going to go ahead and multiply across. So it would be 5 over 33. That would be our answer.